Hello, good morning all. My name is Samir Karadkar, Assistant Professor from KIT's College of Engineering. Today we are going to understand half-wave controlled converter under power electronics and drive subject. So basically in these slides what objectives we are going to cover. The first is we are going to see what is the working of half-wave controlled converter with R load and its corresponding waveforms. As discussed in the previous lecture, this is the diagram of three-phase supply. You can see phase 1, phase 2 and phase 3. They are 120 degrees out of phase. The operation of half-wave control converter for single phase is somewhat different than your three-phase, because in three-phase we are dealing with three phases. Each phase, as I've told you, is 120 degrees out of phase that you can observe in this diagram. Black is indicating the first phase, red is indicating the second phase, and blue is indicating the third phase. Now moving to the schematic of half-wave controlled converter, you can see that there are two parts. First, we have shown on the left hand side the primary circuit, which is connected in delta manner, whereas the secondary circuit, which we are more concerned regarding, is connected in star way. Okay, you can observe that this star connection, A, B and C points are shown, where A point is having one SCR, B point is having another SCR, and your C point is having third SCR. This configuration is also called as midpoint configuration. The reason being that it's a neutral point which is connected across all the SCRs. That is why it is called as midpoint configuration as well. Uh, as you can see, if you observe the diagram carefully, you will understand that because these three SCRs are connected at a single point and that single point is connected to the neutral, only one SCR can conduct at a single time. The elaboration can be more understood in the waveforms. Just observe the waveform. As before going for the waveform, just understand that the phase A, phase B and phase C that I had shown in the previous slide, they are the three phases, and you have to understand here that the phase A is 120 degrees out of phase with respect to phase B, and phase C is 120 degrees out of phase with respect to phase B. So what eventually comes is that at a single time, if you observe the previous slide, you will find that at a single time only one phase is positive with respect to the other two phases. It is more positive with respect to other two phases. So considering that effect, just observe this diagram again. Now we have connected the load here. The load is connected across the neutral point and the common point of the three SCRs. We have shown R and L load as well. Both the loads we have shown here. For timing, we are going to assume that there is no inductance. The inductance is going to be 0 for our assumption. Later we are going to consider inductance as well. So we are going to only consider the resistive load, where only the resistance will be there at the load side. Now moving to the diagram and understanding the operation. Uh, as I've told you, only one SCR can conduct at a time. We can observe this in the diagram. So if you observe this diagram, these are the three phases that we had shown earlier. Now, as I've told you, the reason why one SCR can conduct at a time is because just observe these crossover points in the waveform. As I've told you, this is one waveform, this is one phase, this one is your other phase, and this is your third phase. So only one phase is more positive with respect to any other two phases. So the SCR can be turned on at this point only. This is the point which we are calling it as 30 degree alpha, or alpha is equal to 30 degree point. The reason that the alpha cannot be below this point is that if you observe the diagram again, if I make any SCR forward biased for a single time, this forward bias SCR will create a reverse bias across the two SCRs, the two other SCRs. That is the reason why only one SCR can conduct at a time. And if you want to understand the reason why the alpha angle is not below than 30 degrees, which we have shown in the next diagram. It cannot be here. It cannot be between 0 and 30 degrees. The reason is that if I make alpha below 30 degrees, if I want to switch this SCR, suppose this is my first SCR, SCR1. If I turn on the SCR at this point, the reason that it will not turn on is because just observe this red diagram, which is of SCR3. SCR3 is conducting in this region. So if I switch my SCR on here, the problem is that my previous SCR puts my new SCR in reverse bias. So it is not possible for me to make my SCR on up to this point. At this point, what is happening is my previous SCR is going through some degraded voltage level and my SCR is increasing its voltage from this point. So what is happening is, if I try to turn my SCR on at this time, it is possible because no other SCR is on at this time. So just try to understand the waveform. My waveform will come like this. This is because my SCR, only single SCR is on at a single time. This is my third SCR, this will be my first SCR, this will be my second SCR, this will be my third SCR. Again, it will follow the same path. Again, one thing is to be observed is that one SCR, if you consider this as 30 degrees, it will conduct to 30 degrees to 150 degrees. So you can conclude that one SCR can at the most conduct for 120 degrees. It cannot conduct beyond that because of the commutation that will happen and because of the reverse bias that is being put by the other two SCR, by the other conducting SCR. So your SCR can conduct at the most for 120 degrees. Now this is regarding the minimum case. You can turn the SCR on at alpha is equal to 30 degrees. But what beyond that? Is it possible for me to conduct my SCR? Is it possible for me to make my SCR conduct after the 30 degrees? So it is possible. So in the second diagram, you can observe that I have increased my alpha angle by 30 plus 15. Just don't confuse between this 0 and 50. This 0 indicates that it is 30 here. So this 15 is 30 plus 15, that this will be 45 degrees. Okay, so I'm making my SCR on at 45 degrees. It will conduct for the duration that my next SCR is turning on. Again, it will be 40. So this duration is also again 120 degrees. Alpha angle, we have to carefully set the alpha angle. Accordingly, you will get the mean output voltage. Now again, observe the third diagram. Third diagram is somewhat different than the first two diagrams. In the third diagram, my alpha is set to 30 degrees. So it is actually 30 plus 30, it is 60 degrees. My alpha is turning on here, it is going down by natural commutation. Again, it is turned on here, it is going down. So if you observe the first three diagrams, you can say that the alpha, because of the alpha being 0, 15 and 30 degrees, you can observe that there is a continuous kind of conduction. There is no discontinuity in the conduction. But if I increase alpha further, if I increase alpha is equal to 60, 60 is equal to 60 means 60 plus 30, 90 degrees. So at this point, you can observe that there is a 0 degree voltage level or 0 volt level. So at this point, you will observe that my conduction is not continuous. That is why the value of alpha, anything greater than 30, is called as discontinuous mode of conduction. You can observe this in the next diagram as well. In this diagram, same things are shown again. Pi by 6 means alpha. This is called as continuous mode of conduction. If I start increasing my alpha value, I have increased from pi by 6. Again, I am increasing alpha value. You will observe that this is the last point which I can call it as continuous mode of conduction. But if I increase my alpha value beyond this, this will become somewhat like in this last diagram, and you will observe that because my alpha is greater than 30 degrees, my conduction becomes discontinuous. Discontinuous means the voltage at these points is not there, it is 0. So what we have studied in this diagram, if I want to summarize my slides, we can say that half wave controlled converter operation, only one SCR can conduct at a time, and SCR can conduct maximum for 120 degrees. You can make it lower, but it cannot go beyond 120 degrees. No SCR can be triggered below 30 degrees. The reason we have already stated is that because one conducting SCR puts other two SCRs into reverse bias, and that is the reason why my alpha angle cannot be below 0, below 30 degrees. If I put my alpha angle below, between 0 and 30 degrees, the other SCR will again, or other SCR will eventually put that into reverse bias, and eventually no SCR will be triggered. So thank you for listening to this slides. Again, if the references are the diagram that you have seen, the diagram was taken from Power Electronics MD Singh and KB Khanchandan book. Thank you.